Welcome to this series of introductory lessons related to the time value of money. My name is Brent Pritchard. I teach college finance courses, and I'm here to help you grasp this all-important concept. This introductory series is designed to help you learn how to apply the mathematics of finance in less than a month, provided you commit to one or more lessons a day. It's that easy. Acquiring the hard skill that is the mathematics of finance does not need to be hard. I hope you enjoy this fun new take on this age-old concept. And after you've done that, please consider telling your friends about this channel, TVM Rules, and the book, Would Your Boomerang Return, also known as the Boomerang Book, that made it possible. I like to start every class with a quote. So here we go with a quote of the lesson from Thomas Jefferson. If you want something you've never had, you must be willing to do something you've never done. The focus of this lesson is on the perfect timeline. You heard that right. Not just any timeline, the perfect timeline. Of course, there's really no such thing as a perfect timeline. I'm not referring to straight lines or symmetry, rather an illustration that can help business students see how the building block time value of money equations interact with the timeline and specific payments. So what I mean by the perfect timeline really comes down to how to think about the timing of a value, whether that's a lump sum payment or a value for a series of payments, the latter of which is known as an annuity. In other words, is the present value as of one period before or as of the first payment in the series in the case of an annuity or perpetuity, or is the future value of an annuity as of the last payment in the series or as of one period after the last payment in the series? That was a mouthful. Now, I'm not sure if you picked up on this, but that last long question covered 6 of the 9 building block time value of money equations, 6 of the 8 that deal with present or future value. And this leaves only the building block future value equation and the building block present value equation. The building block true investment yield equation is a kind of unicorn that doesn't deal with either present or future value. However, ironically, lowercase I, or the true investment yield, is the value activator in any one of the building block time value of money equations, as time and money don't get you anything more than storing your money under a mattress. It takes time and value, think lowercase I, the true investment yield, and money for your money to grow and compound. Discounting is the opposite of compounding. Determining the present value is an exercise in discounting. Calculating the future value is an exercise in compounding. It's the perfect timeline because it includes all the building block time value of money equations that relate to present or future value, jam-packed into a timeline that's as short as it can be. But there's more. Note how the tip of the arrow resembles the letter V. This reminds us where the present or future value is under the timeline in relation to the first or last payment for an annuity or the first payment for a perpetuity. FV and PV could have gone anywhere on this timeline, but it made the most sense to place them in the middle to solve for the future or present value related to the annuity or perpetuity. And speaking of annuities or perpetuities, do you see the pattern between the ordinary annuity and annuity due values and the ordinary perpetuity and perpetuity due values? It's the add-on expression, 1 plus I in parentheses, that moves these ordinary values one period to the right below the timeline. Remember, it's ordinary for values for an annuity or perpetuity to be as of one period before the first payment in the series. And last but not least, did you pick up on the fact that this timeline is silent with regard to how we're telling time in between period markers or payments? This is to illustrate a point. Does the space in between each time period marker represent a year, 6 months, a quarter, a month, a week? This is an important question because we can't compound or discount monies below the timeline unless we have an I, lowercase I, true investment yield that matches lowercase n. That is how we're telling time in between period markers. And this is where the building block true investment yield equation comes in handy. So there you have it, the perfect timeline. So with respect to the perfect timeline, we have a couple questions that we want to answer, and we don't want these to be problems. So let's get to answering these questions on the next two slides. So the first thing that we're going to do is draw the TVM wallet. If you've watched any of my other lessons, you know that the TVM wallet is the visual aid that is the solution to analysis paralysis when it comes to analyzing and evaluating real-world time value money situations. I don't know about you, but I'm a visual learner. A lot of my students seem to be visual learners, and this visual aid can help us apply the mathematics of finance. So we want to visualize what we've got going on here in the first window of the TVM wallet. And what we have here is I guess the kind of the leftmost section of the perfect timeline. It's been my experience that when students see the perfect timeline for the first time, they can maybe get overwhelmed with the values, all of the abbreviations for such values as the present value of an ordinary perpetuity, and their heads can spin a little bit. But what we're going to do with this segment of the lesson is to deconstruct the perfect timeline. So again, I'm going to draw the perfect timeline up here just for everyone's benefit. I'm going to recreate it. This is probably the last time I'm going to do this in this lesson, but it's still good to kind of see what we're talking about. And here's the symbol for infinity, and we've got $100 here. Let's see, I think we have $100 here, and then we wanted to solve for the present value of an ordinary annuity, present value of an annuity due, future value of an ordinary annuity. See that letter V, the tip of the arrow, future value of an annuity due, present value of an ordinary perpetuity. There's the V again. There's values as of, present value of a perpetuity due, the values as of the first payment. And then we switched it up here. We had future value first, and then present value. So that's the perfect timeline recreated. So notice how we're just focusing on the leftmost side, this $100 annuity. So the PMT payment is $100. We're solving for the present value of an ordinary annuity. So we're going to circle that. And we're going to put OA in parentheses because we can. That's what we're solving for. We were told that the true investment yield is 5%. That's great. Normally, we fill in the blank with how we're telling time. We don't know how we're telling time, but we do know that we were provided with a true investment yield, and that's great because that's the only rate that will fly. That's why I call I, lowercase I, the butterfly rate. It's the only rate that will fly. What does that mean? That you can use to compound or discount monies below the timeline. That's where I think the action happens, below the timeline. There's a relationship between the PMT payment and uppercase N. So the way that we read this is there are two $100 payments. And when we solve for the present value of an ordinary annuity, we get negative $185.94. If you've watched any of my lessons, you've probably heard me talk about that one word that I think about when I think about the time value of money. It's indifferent. So let's talk about that here. You would be indifferent between $185.94 today and $100 one period from today, because we don't know the time span in between period markers, and then another $100 a period after that, provided you expected you could earn a true investment yield of 5%. So that's what it means to be indifferent. What's really happening here below the timeline, by way of what I like to call indifferent lines, is discounting. And in the elbow, we have divided by 1 plus I raised to the power of 1. And then over here, we have divided by 1 plus I raised to the power of 2. So we're discounting that $100 payment back 2 periods. So that's what your calculator is doing. Let's move on to the next TVM wallet, which builds on the last. Again, I'm not going to recreate the perfect timeline, but I wanted to show you how we're deconstructing that perfect timeline that's as jam-packed as it needs to be. It's perfect because, like I said, we fit 8 of the 9 building block time value of money equations that deal with present or future values into that perfect timeline. So we solved for the present value of an ordinary annuity on the last slide, and we got $185.94. The true investment yield will be the same for every one of these questions. And right here, that was the value as of time period 0. Now we want to solve for the future value, so we're going to circle that. But remember, so I'll draw just a portion of the perfect timeline, okay? Remember that the last payment in this annuity happens at the end of the second period. Now, there's one thing I want to point out here. This is the first period. This is the second period. Seems intuitive, but not everyone understands that. And more importantly, this is the beginning of the first period. This is the end of the first period. Similarly, this is the beginning of the second period. This is the end of the second period. So, do you see how the end of the first period, the actual end of the first period, is the same as the beginning of the second period? That's important. It's just important to know that when we're applying the mathematics of finance. So now we want to compound these monies. Again, the action, what your calculator is doing, the action happens below the timeline by way of what I call indifferent lines. And here, in the elbow, we see it's times 1 plus I raised to the power of 1 because we're compounding one period into the future. That's why uppercase N takes the value of 1. And when we solve for the future value, we get $195.24. Now, remember the perfect timeline. There's our V for value. And the value here is the present value of an annuity due, because the present value of an annuity due is as of the timing of the first payment. So while we're using the FV key to calculate for this, what we're really solving for, let's round out the F and make it a P, is the present value of an annuity due. That's really what we're solving for. But again, we're using the FV key using the financial calculator. Okay, on to the next question. Again, we don't want this to be a problem. On to the next question. We draw our trusty TVM wallet. This is the solution to analysis paralysis. We walk through the 3-step systematic approach. And again, I'm writing in the key variables in the building block time value of money equations, the keys on your financial calculator that you're probably going to be using more often than not. And this next question asks us to solve for the future value of the ordinary annuity. So we're going to circle that, put an OA here to remember what we're doing. We have a $100 PMT payment. 5% is our true investment yield. That hasn't changed. And again, there's a relationship between PMT payment and uppercase N. How do we read it? There are two $100 PMT payments. And when we solve for that, we get $205. Let's add a couple words to this. So in the elbow, we have times 1 plus I raised to the power of 1, because there's one compounding period. But you pick up on the fact that the last payment in this series doesn't go to work earning a return on investment. It's only this $100 amount right here that works for one period, earning a true investment yield. So that's the future value of an ordinary annuity. Remember, timing is everything. So timing as it relates to future value for an annuity, for an ordinary annuity, it's as of the timing of the last payment in the series. And this all comes back to the building block time value of money equation. So the building block future value of an annuity due equation, let's go back to the perfect timeline and just draw a portion of it. Future value of an annuity due. Future value of an annuity due. That's an equation. That's one of the 9 building block time value of money equations. And while we're talking about it, let's just write it out. Future value of an annuity due equals the PMT payment times 1 plus I, that's a true investment yield. It's a lowercase I, raised to the power of uppercase N minus 1 over I times 1 plus I. That's the add-on expression. That's what moves the value from the future value of an ordinary annuity to the future value of an annuity due. So all of these acronyms below the timeline, they just relate back to 8 of the 9 building block time value of money equations. So there we go. We solve for the future value of an ordinary annuity, which is, look at this, as of the timing of the last payment. So you probably know what's coming next. Now we're asked to solve for the future value as of the end of the third period, which is really just the future value of an annuity due. Future value, we can put an AD here in parentheses to remind us what we're doing. We're solving really for the future value of an annuity due. And there's just one compounding period. Times 1 plus I raised to the power of 1. Now, why no PMT payment? Well, because we've compounded those payments already, and they've turned into this hypothetical lump sum that is $205. Now, I want to point something out. Notice how on the last slide we calculated the future value of an ordinary annuity as of the end of the second period. $205. It had a positive no sign value. This is what I call the switcheroo, because we've switched the sign and we've also switched the value from the FV register to the PV register in this case. That's what I call the switcheroo. And we do that to ultimately calculate the future value of an annuity due. Again, I'm just going to sketch out some of a small portion of the perfect timeline. This is where we're at here. We're still working on the leftmost side of the perfect timeline. And we want to know what's the future value of this annuity as of the end of the third period, which if it quacks like a duck, it's a duck. That's one period after the last payment in the series. So future value of an annuity due is that equation that will support the math. Remember, it's always good to know how to double check our work and support our math. We want to support math in finance. And we do that using not only the TVM wallet that is a visual aid, but also the building block time value of money equations. So let's solve for the future value of the annuity due. And when we plug these numbers into our financial calculator, we get $215.25. Remember, the TVM wallet, that is the visual aid, our solution to analysis paralysis when analyzing and evaluating these real-world time value money situations, is meant to be used in conjunction with your financial calculator. So wherever you are, if you're at home, you're on the road, hopefully you're plugging these numbers into your financial calculator and following along. Okay, now we're solving for a straight future value. And the question was, what's the future value for that amount we just calculated? What's the future value at the end of the fourth period on this timeline? Again, I'm going to write in the 5 primary TVM variables, these keys on your financial calculator that you're going to be using more often than not. And we want to know, so see how we're moving to the right on the perfect timeline? We're getting there. So we started with this value, 215. Again, this is really good to visualize in the first window of the TVM wallet. This is great for visualizing. All the cool kids are doing it, right? The Olympians are doing it. 215.25. That's our present value in this case because we want to discount, we want to rather compound those monies one period into the future. So again, the action is happening below the timeline by way of what I call indifferent lines, and that's what it looks like. And we're solving for future value here, and the future value is 226.01. So let's talk about indifferent, being indifferent, the whole idea of being indifferent. You would be indifferent between $215.25 3 years from now and $226 and a penny 4 years from now, provided you thought you could earn a true investment yield of 5%. So that's the return on your investment, the expectation for return on investment. So there we go. We're working through this. Now we get to the perpetuity. So now we're on the rightmost side of the perfect timeline. And let's draw our TVM wallet. We've got our 3 windows. In the second window of the TVM wallet, I'm going to write lowercase I, that is the true investment yield, in this case 5%, and uppercase N. In the third window of the TVM wallet, I'm going to write in the different kinds of payments, as I think of them, PV, FV, those represent lump sum or hypothetical lump sum payments, as we've seen in this lesson and in others, and then the PMT payment that relates to an annuity. And remember, a perpetuity is just an annuity on steroids. 6, 7. Here's our symbol for the abridged timeline, and then there's the symbol for infinity. And this is just the rightmost portion of the perfect timeline. And we want to know, what's the present value of the ordinary perpetuity? We'll put OP in parentheses. Now, nowhere in the question, I don't think, did it say calculate the present value of the ordinary perpetuity. But it did say calculate the present value for this perpetuity as of the end of the 6th period. So that's the end of the 6th period, right? Remember, it's the end of the 6th period. We could also say the beginning of the 7th period. And because the end of the 6th period is one period before the first payment in the series, we know that the building block time value of money equation that supports this math is the building block present value of an ordinary perpetuity equation. So we've got the $100 for the PMT payment, 0 for future value. When you're working with a perpetuity in the TVM wallet, you can input 999 for uppercase N. And when we solve for the present value of an ordinary perpetuity, we get negative $2,000. So that's what will quote unquote buy you this $100 perpetuity. There we go. We solved for the present value of an ordinary perpetuity. Let's move on to the next question. Now we're really being asked to solve for the present value of a perpetuity due. Here's our TVM wallet. I'm going to write in the 5 primary variables or inputs, the keys on your financial calculator, and let's go back to just a portion of the perfect timeline. We've been drawing it up here. There's the abridged symbol, there's the symbol for infinity. And this is what it looked like. And remember we said, hey, pay attention to that arrow. It looks kind of like a V, the tip of the arrow. And you may remember there's our V. That's the present value of a perpetuity due. Why? Because it's as of the timing of the first payment in the series. And it's ordinary for the value to be one period before the first payment in the series for an annuity when you're calculating the present value. So this question really is just asking us to take what was the present value of an ordinary perpetuity and solve for future value. That's the key we're going to use. We're going to use the future value key, but what we're really solving for, look at this, we can round out the F. This is really the present value of a perpetuity due. That's really what it is, right? But we're going to solve for that with the FV key. And when we solve for that, we get $2,100. Okay, the next question is, what is the present value of the $100 perpetuity as of the end of the 5th period on the timeline? I think this is the last question that we need to answer. Again, we're going to write in the 5 primary time value of money variables or inputs, the keys on your financial calculator. And we're going to actually solve this 2 different ways because we can. We'll start with this amount that we just solved for. First, we're going to go up here. We're going to draw the now we're down to the 5th period, which is kind of cool, on the perfect timeline. 7. There's the abridged symbol. There's the symbol for infinity. And remember, this is the rightmost side of the perfect timeline that's dealing with the perpetuity. We've already solved for the present value of a perpetuity due. That's that number below in the FV register, $2,100. And here we're solving for present value at the end of the 5th period. So ultimately, what's really happening below the timeline by way of indifferent lines is we're discounting. So we're dividing by 1 plus I raised to the power of 2. Why 2? Because there are two compounding periods. It's got to go here, and then it's got to go here. So uppercase N is 2. And when we solve for present value, we get, it's a straight present value here, $1,904.76. 904.76. So that's the first way that we can solve for this present value. Now, if we wanted to, we've just been building off of the prior answer, but if we wanted to, we could take that $2,000 value that we solved for earlier and this is the present value of an ordinary perpetuity. Again, we're just solving for a straight present value here. We're just dividing by 1 plus I raised to the power of 1 because there's just one discounting period. Again, divide by 1 plus I raised to the power of n. In this case, it's 1. And we get the same answer. So hopefully that was helpful. Now, if you've watched my lessons, you know that we like to double check our work. We're not going to be double checking any work here, but I want to point out a couple of things. First, I wanted to give you a slide with the 9 building block time value of money equations. Like we do, we usually write the building block true investment yield equation out in the upper right-hand corner. That's why I placed it there. So it's by design. But I also wanted to organize the other 8 equations into present value equations and future value equations. So hopefully you can see how 8 of the 9 building block time value of money equations ultimately come down to present value and future value. So that's a wrap. If you like what you learned in this lesson, please consider telling your friends about this channel, TVM Rules, and the book that made it possible. Timing is everything. It's what separates the good comedians from the great ones. And speaking of comedians, you don't want to get laughed out of a boardroom because you can't apply the mathematics of finance. Now, I'm sure you're amazing, but there are lots of people who can do the job that you dream of. Some of the best advice that I ever received was be yourself and everything will be fine. And that's definitely part of it. But you also obviously need to be proficient in your field of study. And this is where the book Would Your Boomerang Return comes in. This small handbook is perfect for your backpack and journey in the classroom or in corporate America. If you haven't purchased your copy yet, all the important information on this all-important topic is gift wrapped within the cover of Would Your Boomerang Return. Until next time, enjoy the gift that is the present.